Assalamualaikum. In this demonstration video, we will be presenting a high-performance liquid chromatography HPLC. And this is our team members. And this one is the contents that will be discussed in this demonstration video. I am Nur Shawani binti Abdul Aziz and I will be presenting the introduction of the HPLC. First, HPLC is an abbreviation for High Performance Liquid Chromatography. It is a technique for separating, identifying or quantifying each component of a mixture. The mixture is separated using the basic principles of column chromatography, then identified and quantified using spectroscopy. Furthermore, HPLC is a powerful analytical tool. This is due to the forcibly pumped mobile phase where it produces high performance with rapid speed in comparison to the traditional column chromatography as you can see in the picture below. In actuality, HPLC greatly improved upon column chromatography, and in HPLC, a solvent is pushed under a high pressure up to 400 atmosphere rather than being allowed to flow through a column under gravity. Next, the sample preparation in HPLC. A reproducible homogeneous solution that is appropriate for injection onto the column is produced during the important phase of sample preparation in HPLC analysis. The sample preparation's objectives are: it must be interference-free, not cause damage to the column, and work with the HPLC process. The sample materials can be distinct as organic and inorganic and further divided into solid, semi-solids, liquids, and gases. However, liquids are more simpler to prepare for HPLC than gases or solid. Moreover, it is necessary to process solid and semi-solid initially by reducing the particle size of the sample. And because of its homogeneous, more samples may be taken with greater accuracy and precision. For an accurate assay, sample drying to a consistent weight is typically required. Lastly, due to the harmful effect on the column, the particles should be eliminated during filtration before injection. Also, it contributes with producing excellent, repeatable, and accurate results. The HPLC filters is between 0.25 and 2 micrometer.
Next, I, Aini Sofia, will continue to present the component of HPLC. The picture of the HPLC system mainly consists of a solvent, a pump, an injector, a column, and a detector. In addition, the cursor autosampler per column or guide column and column temperature controller can also be configured as required. Firstly, the solvent can refer to the mobile phase that used to separate components in a liquid sample. Next, the pump is one of the most important components of the HPLC system, generating the flow by back and forth motion of the motor-driven piston. Pump can be classified into constant pressure pump and constant flow pumps according to the factors of constant output liquid. The performance of the pump directly affects the quality of the entire system and the reliability of the analysis results. Then, the injector is used to inject the sample to analyze in the HPLC system. The autosampler technology, which is an auto-injector, can also be used to enable repeated injection at predetermined scheduled times. And inside the column, they act as the stationary piece. The separation of the sample component was performed in here using various physical and chemical parameters. Detector was used to observe the obtained separation. When analyte is not present, the eluent composition is constant, while the eluent composition is altered by the analyte's presence. The measurement of these differences is what the detector performs. Next, in this slide, we can see how the HPLC works in this schematic diagram of HPLC picture. First, a liquid sample is injected into a stream of solvent mobile phase that continuously flows through a column packed with a separation medium stationary phase by the pump. Sample components separate from one another by a process differential migration as they flow through the column. The guide column principal purpose is to shield the main column from contaminants. Next, the sample separation will be detected by the detector. By using this cursor, air bubbles of the solvent can be removed, as this bubble may damage the stationary piece, which is the column.
The technique used in HPLC is the separation technique. There are two modes of separation, which are reverse phase HPLC and ultra high performance liquid chromatography (UHPLC). Reverse phase HPLC is a liquid chromatography technique that involves the separation of molecule based on hydrophobic interactions between the solid molecule in the mobile phase and the ligands attached to the stationary phase. In reverse phase HPLC, the stationary phase is a non-polar phase, while the mobile phase is a polar organic solvent. The mobile phase passing over the hydrophobic stationary phase is a polar solvent containing the solids. Ultra-high performance liquid chromatography is used predominantly to identify, quantify, and separate components of a mixture of complicated samples such as botanical, dietary supplements, and biological samples by using a high pressure to push solvent through the column. In UHPLC, particles size less than 2 micrometers can be used, providing a better separation as it requires higher pump pressure. There are two types of analysis in HPLC, which are qualitative and quantitative analysis. First and foremost, qualitative analysis aims to answer the question, what is in a sample? There are two discrete situations that reside over qualitative analysis. First, the sample components are known. Peak within chromatography need to be assigned to the known components. Second, the sample is completely unknown and we are trying to identify it. Identification of a sample component is performed by comparing its retention time with that in a standard sample. However, if there are differences in retention time between the standard and target components, it can be identified by adding the standard sample to the unknown sample. Analyzing the HPLC collected components by IR or mass spectroscopy enables reliable qualitative analysis. After we identify and interrogate the peaks, the next step is quantification. Quantification uses peak areas or height to identify the concentration of a compound in the sample. There are two methods for quantification, which are external and internal standard methods. So both of these methods use a calibration curve. The curve is created by injecting an liquid of the calibration, which is the standard solution of known concentration, and measuring the peak area obtained.
My name is Aida Kasrina, and next I will explain about the application of HPLC that are most widely applied, where among them is application in the clinical. In the clinical, HPLC provides an efficient and rapid analytical approach in the quantification of drugs in body fluids to confirm the identity of a drug. Furthermore, in the pharmaceutical industry, the application of HPLC serves as a quality control and shelf life of a synthetic drug product. Furthermore, for the environment, chemical detection in drinking water can be discovered where it is likely to identify the detection of phenolic compounds in drinking water. According to Sharma and Nagy 2020, organic contaminants such as pharmaceuticals and pesticides are commonly found in drinking water samples. Besides, HPLC will be used in forensic to analyze textile dyes. Textile dyes are classified into numerous dye classes such as reactive, basic, acid, direct, and dispersed according to Kiran 2021. The separation and identification of a complex mixture of natural and synthetic textile colors can be accomplished utilizing HPLC with diode array detection. Following that, in industry, HPLC is applied to test the stability of chemicals in food products, where, according to Auriga Research 2018, the stability of a food item refers to how long it may be stored without apparent modification or a change in taste or flavor. The modification of food could be physical or chemical. Lastly, during research, HPLC is also useful for separation and isolation of components from nature samples from animals and plants. HPLC has limits as well, such as the cost of high pressure generation. High pressures impose some constraint of instrumentation. Relatively, it has low flow rates. As a result, time consumption is also slow. These issues can be solved by lowering the pressure and increasing the flow rate for comparable analyte resolution in HPLC and perfusion chromatography. Next, increase the instrumentation can be withstand high pressure by considering cost economics for better resolution than HPLC UPLC.
Because HPLC is also beneficial for the separation and analysis of lower molecular weight biomolecules, it is not often used for the purification of complex polymers such as in active form. The reason for this is that some HPLC formats, such as reverse phase chromatography, require organic solvents that denature protein. Although larger HPLC columns are available, they are costly. So, the other problem can be handled by the development of another format for biopolymers, FPLC.
Advantage and disadvantage of HPLC. So what is the advantage of HPLC? The advantage of HPLC are fast and efficient separation. Continuous monitoring of the column, even also it can be applied to the separation and analysis of very complex mixture. Furthermore, HPLC is more versatile than GLC in certain ways, since it is not restricted to volatile and thermally stable solute, and the choice of mobile and stationary phase in HPLC is significantly broader. Next, the benefit of HPLC are accurate quantitative measurement, repetitive and reproducible analysis using the same column, and also adsorption, partition, ion change, and accretion column separation are excellently made. Lastly, a part of its advantage, HPLC also has its disadvantage. The disadvantage of HPLC include its high cost, complexity in operation, low sensitivity for some compound, difficulty in detecting coagulation, and irreversible adsorbed compound were not detected.